This conference will now be recorded.
या मैं अरे उन सबको बोल रहा हूँ, एक बार आप भूषण को बोल दो ना, मैं इन सबको बोल रहा था ज्वाइन। प्लीज ज्वाइन द सेशन। Yeah, hi folks. I mean, we are actually looking for more people to join, so we can, maybe we can start the session in next 10 minutes from now. I hope it's a good point. Give me a thumbs up in case you can do, or maybe a reaction. Yes, I have Malar Vanan right. He was one of the first person to join. So Malar, how's the day so far? Arun, you are on actually on camp. Malar Vanan.
I'm sorry, sir. I think
Okay, I mean I believe that everyone is fine after the Shera, right? Is there someone is going to speak? Yeah, Bhushan has said me that yes. What about Mr. Morgan? I mean, I want people to speak because at this point of time, in case we don't speak, it cannot be an interactive session. As simple as that, right? I have Jana out here. I have a lot of other learners also. Sandeep Kumar, I do have. Okay, excellent, Jana. Wonderful. So what I want an expedition from you guys. So once my trainer, she is there. Her name is Zainab Siddiqui. She has a very good experience trainer, and she is one of the from the Premier Institute actually. She has done her master into data science. So I would ask that to make the session more interactive so that because it should not be a boring kind of session. I understand it's a master class, a lot of master class happens, so I want the session to be at a very very par excellence. So so that we can we understand the same thing, and then we can build up a community, and then we can enhance those things for our future growth, as simple as that. And then we'll come to your discussion also, wherein you would be focusing on a lot of things about your career goal, about your introduction, about how exactly you should make your career journey, so that we can inculcate the same thing and pivot towards a very excellent way. All right. Sure. So let us wait for more 10 minutes. So let's, and then we can start the session. I have a lot of other people has joined, but I'm expecting some more people. Yes. In the meantime, can I get some introduction from our students or maybe the learners? I can start with Malar. In case you can tell us something about yourself, please, so that we can understand that. Malar, am I audible to you? Malar, is it a yes or you're not? Am I? I believe that am I audible to everyone, right? Yes, and thank you. So, Mr. Morgan, you can always introduce yourself in that case, please. You have to unmute yourself and then you need to introduce yourself. Or maybe I can start with anyone else. I mean, anyone take an initiative, please.
So Subir, hi Subir.
Yes, hi, Zinab, please.
Yeah, so right in are like more people joining, or we can start,
That's what
or in
exactly I'm waiting for till 2050 so that we can start.
okay. Otherwise, in the meantime, we can have some discussion over the whiteboard related to the job profiles that are available in this domain, maybe. Uh,
Yeah, yeah, absolutely. That's right.
right, because why waste the time of people who've joined, and then we'll
Absolutely,
start
absolutely.
with
That makes
today's discussion on advanced AI and generative AI. So that would give them
absolutely
clarity as to what is available out there in the industry, and maybe then people would get the courage to speak up and ask questions. Let's break the ice. Okay.
sure, sure, definitely.
All right, so I'm sharing my whiteboard. I hope my screen is visible, right? Please let me know in case my screen is visible. All right. So right, see, what we commonly know, the very common term that is quite available to each one of us, right, it has become a very common household term, but 10 years, 15 years back, this was something fancy nobody knew about. But today it's, all around every nook and corner. You'll have people talking about data science, right? What is this data science? It's science about data, or it's data related to science, what it is, right? And actually the confusion amongst people is uh, obvious. Why? Because it's a very broad field. Some people think that it is entirely about robots, making robots, right? Some people think it is entirely about making chat gpt, right? Other people would think it is about creating deep fake videos, right? That's what a data science come. Some people would say this is data science is related to ai, right? Again, all of these terms are interrelated, but there is a sequence, there is a hierarchy which people are not aware of, right? Then some people would also talk about machine learning, deep learning in between, right? People also talk about analysis and dashboards, right? People will say we can make dashboards. Then these are there. Then a couple of software. Some people will say data science is all about python, right? The term python comes into the picture, right? So different people, you ask what is data science, different answers will come up, right? And but the confusion still exists, and the reason is that it's a very broad field, right? So primarily, if you say, what if you are to define what is data science, it is the science related to data. Everything you can do, all possibilities with data, right? Doing analysis, creating models, creating systems, or creating entire chatbots, creating entire robots, creating autonomous cars like Tesla is working on those projects. All of that thing complete, the umbrella under which everything falls is data science. Now we are primarily concerned with the AI wing of data science, right? All of this is under data science. But if we talk about AI, right, this is the thing which is leading the future, or the wave of future. We are actually riding the AI wave currently, right? So AI is a very broad term, right? If I make this circle is all about AI. Now, within AI, we have another subset, another big subset of AI, a very large portion of AI, which is known as machine learning. So here we are actually creating mathematical models, okay, for modeling our data. We have data, historical data, and based on that, we are trying to predict the future. This entire realm within AI is known as machine learning. And within machine learning, we have another subset which is known as deep learning, right? Now, people know the term, but what is the, what why we are saying deep learning is a subset, why we don't say deep learning is the same thing as machine learning? Nobody knows, right? Because the basics are not clear, and that is where the awareness starts, right? You should be aware about the basics to get, like, the familiarity with the basics is very important. And after, within deep learning, again there is a subset, right? This small subset of deep learning, this is what is known as generative AI. Okay, so again, all of this entire field of AI is not purely about analysis, it's not purely about creating any architecture, it's about creating models. And models, if they are plainly mathematical models, it's machine learning. If they are plainly models which are trying to mimic our human like brains working, it's deep learning. And then within deep learning, it's generative AI, where the model creates something new, whether it's an image, whether it's an essay, whether it's a script, whether it's an entire video, right? So this is the actual distribution. Now, talking about the profiles, right, that are available out there in the market. So I'll mention this in the hierarchy, how it happens, right? If you are a complete fresher and you set out in the field of data science, right? So the first profile that is available to you is of a data analyst, right? Where you are purely doing analysis, you are working with tools like Power BI and Tableau. You're trying to build dashboards, right? That is the very first profile that is available to you, and this is the very beginner level profile. I should say the starting point of your journey, right? The starting point of your journey in the field of data science. After data analyst, you can be a machine learning engineer, right? This part. We also have a profile for AI engineer, right? But then if you are an AI engineer, you are required to have knowledge about ML, DL, Gen AI, everything, right? So that is, the very last, I would say, the profile in the ladder, right? So it's an AI engineer. We say AIE. So after data analyst, you can be a machine learning engineer where you are creating mathematical models for based upon historical data and trying to predict something in the future, just like stock price prediction, right? You have historical stock price data and you are trying to do predictions about the stock prices in the future. So that is the ML engineer profile. Then after ML engineer, you have one more profile which is known as deep learning engineer, right? So when you are an ML engineer, you are majorly concerned with this part. You are not supposed to have knowledge about deep learning or generative AI. Even if you don't have, it's fine, right? You can do, because here the work will be related only to mathematical modeling. After that, you have deep learning engineer, which where we have neural networks. So neural networks, the term comes from your neural structures in your brain, in the human brain, and the algorithm is actually trying to mimic the functioning of the human brain. So deep learning engineers, you are required to have complete knowledge about machine learning, deep learning both, and you are primarily concerned with creating neural network architectures, working with images, working with text data, working with video data. Here in MLE, data will be mostly tabular, right? Or tabular, or you can say numerical data mostly, right? But when you go towards deep learning, you can have different kinds of data, different modalities will come into the picture, right? And after deep learning engineer, you have two further bifurcations in this domain only. One is of a computer vision engineer, which is known as CVE, and the other one is an NLP engineer. Okay, we'll be talking about these fields also. So computer vision engineer, this is primarily for working with image data. Okay, and NLP engineer, this is primarily for working with text data. So these are the further bifurcations, and these are specialized areas, right? If you have started working in deep learning and you want to focus yourself on working with images, you go to the profile of computer vision engineer, there are dedicated profiles, right? You have to be excellent in working with image data. And the NLP engineer, this is a dedicated profile for working with text data, right? Like we talk about chat GPT, that's an NLP product, right? But if we talk about DALI, we talk about Mid Journey, which are popular generative models, those are computer vision related stuff. Okay. After this thing, we have another important uh, profile which comes as data scientist, right? So again, data scientist and AI engineer, these are kind of equivalent profiles. Here you need to have knowledge about everything, and even in AI engineer you need to have knowledge about everything. So it slowly moves you, like you slowly move ahead the curve. And recently a new profile has come up, which is Gen AI engineer. So as a Gen AI engineer, you are majorly concerned with fine tuning the models. You are majorly concerned with developing uh, generative AI models based upon what is pre-existing in the market, right? So this is just a brief overview of the profiles and what data science is, everything. Again, Python is a very important part of all of this, but I hope you get an idea of like what all comes under this, what all falls under the umbrella of data science, and what are the different profiles available. Just a brief idea, right? Anyone would like to say anything? I would like to ask at the moment. Otherwise, I think it's time we can start with the agenda for today's masterclass.
Hello, ma'am. I have one question.
Yes, please, Bhushan. But your voice is very low. I mean, the volume is very low. If you can speak a little bit louder.
Okay, is it audible?
Yeah, now it's much better.
Okay, so I just want to know one thing, like how much math should I know for entering in this field?
How much math? You should be knowing
Yeah.
probability, you should be knowing statistics, you should be knowing matrix, then integration, differentiation, right? Most of the concepts which you must have covered in class 12, that is required. But apart from that, logical thinking, creative thinking, that is very much important. Like it has to be a combination of skills. If not pure maths doesn't comes into the picture, right? And
Oh,
all the things are managed by code, so you don't have to do any hardcore calculation. You have to understand how it's working in the back end.
okay, so non-technical person also can enroll for these things, right?
Absolutely, absolutely. The field is open to each and everyone. You don't have any barriers. Like if you don't know maths, you cannot do Python programming. Python is very simple language. It's very easy to use. It's like writing in plain English.
Absolutely, Zanab. I mean, Python is something which is one of the most easiest language, and it's pure coding on the English as a language. In case you know English properly and you know a bit of with your studies and all do properly, then you can always do that. Thank you, Zanab, for explaining the things. And Bhushan, I believe that your query was solved, right? Or do you have any
Yes,
other
yes,
question?
complete. No, no, no. That's it.
Thank you so much, Bhushan.
Yeah.
Yes. Do you have any other query? I mean, come on. I mean, like we can, interact because I have taken a lot of master class. If I talk about me, I'm more than close to around 24 plus years of experience. So uh, I want a session to be interactive because in case we do not actually make it interactive, sometimes when you come out here, then you might miss out a lot of questions, and then you might think that yes, I could have asked these all questions, right? So I have Ritu out here. She has joined right now. So any question you have regarding, or maybe you can tell about your experience, someone, so that I can help you out, or maybe Zinab can help you out because she is from one of the New York sorry, the Texas universities, and she has passed out from that university. So she holds in and out about data science, machine learning, deep learning. Yes. Anyone do have any question, please, so that we can proceed? Mr. Ashok Gupta, you have joined also. I mean, in case you can write it down or something in the chat box, I'm okay with that also. No worries with that. So Zanab, do you want to proceed with anything more?
No, I think we can start with the masterclass.
Sure, sure, please. Absolutely.
Yes, we can go
Absolutely.
ahead with the agenda for today's masterclass. And
I can't see.
Yeah,
the
Mr.
screen is
Ashok
not
Gupta.
shared.
Mr. Gupta, I mean, in case you can tell something about yourself also, I mean, that would be
I
really
can't see,
appreciated.
sir.
Yeah, this is the master class. I
Okay,
mean,
okay.
so Mr. Gupta, can you tell me something about yourself, please, so that we can understand yourself and before presenting the slides, please.
Sir, I'm an architect and by profession architect
Okay, excellent. So, and where exactly you are based in India?
from Delhi.
Oh, Delhi. You are from Delhi itself. Okay, that's
Yes.
great. All right. And so, what exactly, like, I mean, what you are planning, like, I mean, how exactly you're planning for data science, your career? Is it like related to your field you are planning, or you want to change
I have
something?
to understand what is this, then I decide to further.
I would actually wanted to understand, like, how many years of experience you have in architect, as an architect?
About 25 years, sir,
25 years,
in
right?
the field of architect.
All right. So, what are the challenges you have faced in architect? In architectural job, what are the challenges you have faced so that you might be thinking that you are looking for those challenges to upskill yourself? Because if I understand, you are similar to of my age also, like because I have almost like 24 plus years of experience. uh, when actually the computer came to the picture, a lot of people, the bank managers, they were really scared enough in the I'm talking about in the globalization of Indian economy. They were really scared enough, how to flourish into the correct to the career into the next role. But slowly and steadily, the computer came to the picture. So these things are something kind of a upskilling. Even for architecture also, data science can help you out. Business analytics can help you out a lot of way, trust me, and that can actually really give you more better structure towards your architectural job at the moment, and can give you a more better, precise, and better way of experience under your belt. So anyway, the Zena would actually share you a lot of things out here, so she can always give a good and insight about architecture also, in case obviously she knows about the tools and all, so she can always help you out all with that. So Zena, you can start, please.
Okay, thank you, Subir.
You're
Um,
most welcome.
All right. So the agenda for today's discussion, right? I've already given a brief idea of how AI is further categorized, right? AI, then machine learning, then deep learning, and within deep learning we have generative AI. So the part of deep learning and generative AI is what we'll be discussing today, because these are the things which are leading towards the future, right? You can see a robot on the screen, and this is what I talked about a few minutes ago, that if you ask anyone what is AI, what is data science, they would say robots. It's all about creating robots. All about giving robots the ability to work like human beings, right? That's what the image also says here, right? I would just give me a moment, right? So, this is the session outline. We will first have an introduction about AI and how AI has evolved, right? Then, advanced AI concepts. Then, what is the difference between advanced AI and generative AI? We will try to understand that. We'll see a little bit of use cases across industries and verticals so that you are able to understand what exactly is AI and what exactly is not AI, right? Then, we will have advanced AI concept discussion, deep learning neural networks, as I mentioned. I was talking about neural networks, right? So deep learning is all about creating models with the help of neural networks. We'll be saying that. Then convolutional neural networks and its architecture. As I told you, like the field of computer vision is all about creating models for images, right? Image related data, working with image related data, and the convolutional neural networks that is mentioned at the second last position on the slide. These are the primary building blocks of all the models related to images. Then we have recurrent neural network and their architecture. Okay, so recurrent neural network and their architecture, this is the primary architecture which is used for modeling text data. All right, so image data and text data. After that, we will talk about transformers. So transformers is actually the breakthrough technology that came into the picture. There was one research being conducted and by Google actually, and Google released that research paper. The name of the research paper is "Attention is All You Need." You can read through the paper. It's available online for you, like in a PDF format. There they introduced the transformer architecture, which led to the birth of generative AI. So from the point we start discussing about transformers, we are going to talk about generative AI. Right. Then reinforcement learning comes into the picture, where we don't have any labeled data set, nothing, right? But we are training agents. We are training, it's actually the field that is behind robots and self-driving cars, right? We are training them to learn by experience, just like a small child learns, right, at our house, right, or at our homes, right? The child, we are giving rewards to the child, we are giving punishment. So we'll be discussing in detail, right, when we come in the later slides, but I'm just giving an overview. Then real world applications, we'll talk about ethics and biases, right? Ethics are the good practices that we need to follow. Bias is the kind of inclination that we have in our AI models, which we tend to create. Then best practices for fair AI development. Right now we don't have any rules and regulations. Any government regulations have not come up. Maybe in like strong regulations will come up AI, right, in the next 10 years, in the next 15 years. So, but even though regulations are not there, we have to think about the fair AI practices. Our models should treat and should be not used for malicious purposes, right? That's about fair AI. Then we have generative AI models. We'll talk about different types of generative AI models, applications, NLP, and large language models. NLP is the field where we talk about the text data again. Large language models is LLMs, the short form. Large language model, actually, this is the basis of your chat GPT, right? It's capable of generating text. It's a text generation model trained on a very large data sets. You can assume, right, 20 billion, 30 billion sentences. The like that is just, I'm just giving you an overview. That's the size of the data set on which this is trained, and this trains on year, like, or on a month basis. Like the training process goes on for months, and then you have such a robust model like Chat GPT, which can answer almost every query that you put in today. Right. Then we have some we'll see some practical applications and some hands-on and some demonstrations also. So that's the outline about the session. About SkillzRevo, okay, this is a company which is revolutionizing the skills acquisition. We are here providing different courses in generative AI, artificial intelligence, machine learning, deep learning, data science, right? Different curriculums are there, and based on those curriculums, we have a well structured course along with the hands-on projects and live sessions, which will help you learn these, you know, technologies and ride the wave as we go ahead, right? And specially designed for the professionals, not to forget, right? Then this is my introduction. I'm a machine learning engineer currently, working with Anubrain technology, right? And I have worked on various projects, right, from machine learning, deep learning. I have knowledge of all of these things. I've worked on Gen AI projects also, and I'm currently working on all of these things, right? Reinforcement learning, classification, data wrangling, big data analytics. All of these things are the set of expertise. I work with extensive libraries of Python. All of these things are there, and I did my data science and business analytics program from University of Texas at Austin, right? So yeah, so that's a very short introduction that I'd like to give. Rest, I would like you to like listen to me, and you will understand yourself. Then overview of AI and its evolution, right? Coming to the agenda, as I said, when you talk to anyone, you say data science, people would say it's all about AI. Now, what is AI, right? So AI is a field where you are creating machines, or you are creating models that have human like intelligence. Okay, right now we are at a stage where we are trying to give machines the ability to think like us, to see like us, to write like us, right, to read like us. So all of those abilities, right, the cognitive abilities of human beings getting translated into the abilities of machines, that field, that entire field is known as artificial intelligence. You see the term artificial attached to it, right? The term artificial is attached only because the entire field is giving machines the ability based upon the data. Now how this ability comes, that is based upon the data, right? So the early days was 1950s, 1960s. Early rule based algorithms were developed, right? It was purely rule based, that if this then this, if this then this. So that was the early days when AI came into the picture. But 1980s was the point when this picked up pace, right? So 1980s machine learning came into the picture, and as I was like in the earlier part of the session I said, the hierarchy is you go from machine learning to gen AI, right? So machine learning came into the picture in 1980s, where we had simple models, mathematical models created, like linear regression model, we have logistic regression model, we have support vector machines, right? Different models were there, but they were based on one mathematical concept. If I talk about linear regression model, which is a simple machine learning model, it's based upon linear algebra, right? Like someone recently asked what mathematical concepts I should know. So that these are simple mathematical concepts that you should be knowing: how linear algebra works, how you can solve simultaneous linear equations, simple class 12th mathematics. So based upon this equation, a model was created where you could input a set of data points, it would model it on this equation, and it would give you an equation as an output, into which if you put new data points you would get an output. So y is equal to mx plus c. This is a very common famous example that is given for linear regression model, right? So again, it will have certain constant values, it will have certain error values, all of that together, that mathematical model is able to give, and you will be able to predict future values by substituting the data points in that equation, right? Just as we do in maths, right? Simple. But everything is handled by the machine can do it on its own, it can make predictions in the future just by receiving input from a human being. So that was the very early days of AI, machine learning. After machine learning, there was a point where where the researchers, or you can say the engineers, they started feeling that there is a limit to what we are doing currently, right? The limit is that we can only create models where we know the equation, right? Models are governed by an equation, that is machine learning. But how to create complex systems, right? Complex systems will have a lot of applications, right? So when they were trying to use machine learning for working with image data, or when they were trying to use machine learning for working with text data, it became a lot more complicated, and it was not giving results as expected. That was the point in 2010 that we saw deep learning coming into the picture. Now deep learning is a field where we have neural networks. Neural networks, our brains, if you look at the nervous system in our brains, we have neurons creating our brains, right? In the brain we have distributed neurons. Neurons, they receive the stimuli and they produce a response. That is the basic function which we study in biology. Similarly, in neural networks we have neurons. Neurons are also referred to as nodes. In some of the documentation you will find the word node, so it's the same thing. Neurons or nodes, they receive the input data, apply some kind of a transformation on it, and give the response. Now, this transformation is actually based upon a mathematical function, but there's a lot more possibility to do with neural networks. And again, neural networks are black box techniques. They are not white box, unlike the traditional machine learning algorithms, like I talked about linear regression. By the name only, you can make out that it's based upon some linear equation, right? So it's a white box technique where you know what the equation will be. What kind of an equation, at least you can judge what kind of an equation it is going to prepare. But in neural networks, the kind of equations getting prepared, the number of equations getting prepared, nothing is known. So it's a black box technique entirely. And the key part is it mimics the neurons present in the human brain. And that is why it is able to work very well with image recognition, with speech processing, with the text synthesis. A lot more can be done. Now, again, deep learning has its own limits, and this transformer architecture, as I said a few minutes ago, when the transformer architecture was introduced, it has two parts. One is encoder, one is decoder. Both of these together work for the generation part. In the encoder we are giving information, in the decoder we are taking information, right? So 2020s we have seen the rise of generative AI, and I think 2019 or 2018 was the year when this transformer architecture was released in that paper, uh, in the research paper, right? So transformers and this GANs, generative adversarial networks, GANs, the full form is generative adversarial networks. You might have seen a lot of fake videos of celebrities circulating on the internet. That those are created with the help of GANs, right? So deep fakes. Uh, those GANs are responsible for creating those fake videos, right? So this is pretty much it about the evolution, how the things have changed, and we have come to generative AI, and we are slowly heading towards more advanced systems, more complex systems, right? Then if I talk about advanced AI, the the path from deep learning to your reinforcement learning and complex neural networks, that particular journey is known as advanced AI, right? Like you have autonomous vehicles, which are continuously learning to adapt to new environments. Like Tesla is a very popular example, as I mentioned earlier. Also, Tesla is working on autonomous vehicles where cars have cameras that serve as their eyes, right? They are able to detect objects. They are able to decide when to apply brakes, when to make a turn, when to accelerate, right? What route to decide, right? What route to take when if the destination is known, right? So all of that decision making entirely is taken care of by the car. So that is advanced AI. Generative AI and advanced AI, the key difference is that advanced AI, we are creating discriminative models, right? The model is doing some kind of a differentiation of one thing from another. So it's a discriminative model that we are doing in advanced AI. But if I talk about generative AI, we are doing creation of new things. That is the core difference that comes, right? So generative AI, whether you create new images, whether you create new text, you create new piece of music, new video, or an entire new what do you say uh, forget about it. So anything new that you are creating, that falls under the umbrella of generative AI. But again, a model will be able to generate only the type of data it has been trained on, right? You have to understand this. If a model is trained on image data, right, it will be able to generate images, right? If it is trained on text related data, it will be able to generate text. So you have to understand this thing. There's a uh, very strong relationship between the data you use for the training the model and the predictions that come out. Okay. Again, for generative AI, we have GPT, that is generative pre-trained transformer. Again, the term transformer has come into the picture, and that is because transformers are the basis of generative AI, right? So GPT generates human-like text, and DALI is another Gen AI model, which is particularly for generating the images. All right. So here we have certain use cases in healthcare. A lot of applications are there, particularly for medical image analysis. If you're aware about the tumors and cancers, right, where medical images are the primary medium of detecting those tumors and cancers, right? So computer vision algorithms or neural networks working for image-related data, we can say, they are primarily responsible for identifying those tumors with high precision, right? Where human fails, humans don't have that skill set. So there a lot of analysis, like a lot of computer vision algorithms come into the picture. They can highlight the affected area, and based on that the doctor can suggest the treatment plan and take decisions accordingly. So that's about healthcare. You also have like predictions about how many people can are at the risk of a heart disease. All of those things have come up. Finance fraud detection, right? Whether a person is going to be able to pay back a loan, whether a person is going to do a credit card fraud, all of that thing come into the picture. So it keeps on the algorithm, or you can say the AI model, it keeps on analyzing the behavior of the person, and based upon that behavior, it sets an alarm in case an anomalous activity happens, or an unlikely activity happens on the account, right? Like for example, person withdraws all the amount available in the account, it will automatically trigger an attack and freeze the account, right? That this person is going to do a fraud, right? So I'm just giving you example so that you are aware how it happens. Then in media you have content recommendation. Netflix is a very popular example. If you're continuously watching movies which are of the comedy genre or which are of the detective genre, it will start throwing you suggestions of such movies only. So those recommendation algorithms are also powered by AI only. Then robotics and automation, I already gave the example of Tesla, right? And robotics surgery has also come up. So robots with cameras installed in their eyes, they are able to do very high precision surgeries, where human beings, human doctors, they can fail, right? But robots, they will be able to do it with very nice precision. So all of those things has come into the picture. So some of the applications we have discussed, rest we can discuss sometime later. Advanced AI concepts, RNN and CNN transformer. So this is just this is what is the more like very important thing for you to understand, right? So here, if you see, we this is a neural network architecture. This is the neural network architecture. This green part or this blue part and this pink, purple part that you see, these are the neurons I was talking about. Okay, so these are your neurons, and these are the building blocks of your neural network architectures. Okay, the building blocks of your neural network architectures. So the very first green neurons that you see, the two green neurons that you see here on the screen, this is the input layer, and this purple part, it represents the output layer. So every neural network is composed of layers. Layers are composed of neurons. Every neuron will have a certain activation function which transforms the input data into the output data, right? For you, right now it's just the basic part that I'm telling. And you see these lines, these are actually the equations that connect one neuron to another, right? Input from this neuron going to this neuron will be transformed based upon this equation. Again, here you will have another equation, here you will have another equation. So every connection, every neuron is connected to every other neuron, and there are equations. So there can be hundreds to thousands of equations based upon the structure that you use, right? Whatever is the structure, based upon that there will be hundreds to thousands. And if you work with chat gpt, if you've used chat gpt, you will say it has so many billion parameters, right? And or 70 billion parameters. So where are those parameters coming from? Those parameters are actually referring to these equations. Okay, so neural networks are computational models inspired by the human brain. They can recognize patterns and solve complex problems, right? That's all about the neural networks. I hope you get an idea about it. I don't expect you to understand it completely. It's a very, it requires time to digest what neural networks are. Now let's talk about advanced neural network architectures, right? CNN, as I said already, it is based upon your image data. First thing, again, it is inspired because it's a neural network. It is inspired by the brain, right? But the term convolution reflects that it is inspired by the seeing ability, by the ability of the brain to interpret the visual data, right? So it is inspired by the human visual system. Then there are convolution layers which function in the same way as the brain function processes the images. Okay, so brain looks at the details in whatever scene we are currently seeing, and then tries to process it and captures it, right? So that is modeled with the help of convolution layers. After the convolution layer process the images, we have the resulting feature maps. We have pooling layers for doing the downsampling, because feature maps are often very large matrices. Okay, feature maps, actually this is a matrix representation of the image. Pooling layers will reduce that matrix to a smaller matrix. And we have ReLU activation function, okay, which is actually the activation function which I mentioned, right, present in the neuron. So it's a ReLU activation function. This is doing the transformation. Then we have fully connected layers. These are responsible for making the final decision, right? So this is all about CNN. This is a typical architecture. As I said, every neural network architecture has an input layer and an output layer. There are neurons in the input layers and the output layers, and in between you have a lot of hidden layers, right? These hidden layers can be convolution layers, it can be max pooling layers, or any other layer that you want to use in the CNN architecture. But if it is a CNN, it is bound to use a convolution layer. right? Similarly, when we'll be talking about RNNs, I'll tell you that it is bound to use a recurrent layer, right? The neural network part means it is going to have neurons, it is going to have layers, right? But the term that is added before this C or R, that reflects the kind of layer that has to be there in that. So CNNs are the breakthrough technology in computer vision. You can do object detection, you can do classification, you can do segmentation, and then you can create generative AI models also with the help of CNNs, right? So understanding the basics is very important, because until unless you know how the CNN is created, how the convolution works mathematically, you will not be able to get the hang of advanced AI concepts or maybe Gen AI, right? The hang doesn't comes, right? It becomes very difficult. Then we have recurrent neural networks. As I already mentioned, this recurrent neural networks are primarily for text related data. Again, because it's a neural network, it's going to have an input layer and an output layer, and within the between these two we have sandwiched layers, which are known as hidden layers. Now these hidden layers, these can be dense layer, fully connected layer, dropout layer, recurrent layers. Okay, we have simple RNN layer, right? And the library that we use is keras and tensorflow and pytorch, right? So these are the three major libraries which you can say this is a stack that is used for deep learning, like advanced AI and Gen AI. And Gen AI transformers also come into the picture. So it's a transformer is an entirely different library of Python that comes into the picture, right? So here in the recurrent neural network, the neural network part is the same, right? It's going to have a neural network architecture, but the term recurrent reflects that it is going to have recurrent layers. And again, recurrent neural networks, the key feature of these is they work with sequential data, right? Like if we talk about text, right, every word that I'm saying right now is dependent upon the previous word that I said. So there is a sequence in the word order, or you can say a word order in the sentence that I'm speaking currently. And if I try to break this word order, my sentence would not make sense, right? This is the actual difficulty when you want to model text related data with any kind of model, right? When you want to create any model for text related data. So recurrent neural networks, they are especially designed for working with this kind of a sequential data where the word order is preserved, right? Every word. So actually happens is it considers the current word also, and it considers the previous words in the input also, and based on that it gives you the predictions. So the word order is preserved, and that is why recurrent neural networks are able to perform very well on the text data, right? And recently it has come up that this RNNs have also come up for uh, you know uh, the variants of RNNs have also come up, like you have GRU and you have LSTM. So these are advanced recurrent neural networks only. The variants are there, but these variants are capable of delivering much better performance with text data compared to your simple RNNs. Okay. Then we have transformers. This is the basis of your Gen AI. So transformer, as you can see in the diagram below, right, it has part one as the encoder and part two as the decoder, right? So encoder is responsible for processing the input data. And also let me give you a little bit of a background. The transformer, again, the birth of anything and everything, necessity is the mother of evolution, right? So the birth of transformers came into the picture because when people were trying to do language translation with simple models, they faced a lot of challenge, right? The one challenge I've already talked about, that sequential data, it has word order, right? If the word order is lost, the entire meaning is lost. That is one thing. Second thing is the context, right? Supposingly I'm talking about McD and I'm also talking about Burger King at the same time. The my context is about comparison, right? But simple your RNN or LSTM or GRU might not be able to capture that context, right? So for that context understanding, for the intent understanding, the transformer was introduced, which uses a concept called attention, and that is why the name of the paper was also attention is all you need, right? Rest of the parts are very simple, right? It has convolution layer, sorry, recurrent layers, GRUs, LSTMs. It has encoding, it has embedding. All of those things were already existing. The new thing that came into the picture was attention, right? This multi-head attention that you see here, here and here. This attention actually captures the context of the input, Okay, and once the context is captured, it is able to do the language translation much more efficiently. Okay, so this is about the transformers, and yes, they originally were used for language translation, but recently transformers have become the basis of the LLMs, which you see, whether you talk about the uh, Meta AI model that's currently available on your WhatsApp devices, WhatsApp applications also, or you talk about your Chat GPT, everything is based upon, or you talk about Google Gemini, all of these are using some kind of transformers. All of these are large language models, and these are using some kind of transformers for doing what they do. Again, these are two very popular transformer architectures, BERT and GPT. BERT is developed by Google, right? And BERT is a very popular architecture. It's like it is available to be used in various other applications also, right? What it does is it is able to capture the context, as I was talking about the context, right? How the words are related to each other, right? Right. So that is the BERT model. And if you can see in the diagram below, the sentence is splitted into tokens. Every token goes to the encoder, right, where the attention is applied on the input, and based upon that, the sequence, one by one, it goes to the encoder, and in the same sequence, it goes to the decoder, and the corresponding outputs are given out, right? So this BERT was released by Google, as I said. It is capable of doing generation also, and it is capable of doing translation also. So translation is also one kind of generation only, right? And BERT is very widely used. If you have seen self compose in Google Mails, right? I don't know if you guys have seen or not. If you if you use Gmail, right, it gives you an option where it will compose an entire email for you just by seeing the subject line. So that subject line serves as an input here, and based upon that input, it generates an entire email body for you. So that self composes based upon your BERT model only. Then GPT, generative pre-trained transformer, this came into the picture with OpenAI, right? When it released ChatGPT, it made public ChatGPT. So generative pre-trained transformer. Uh, Again, the working is same as BERT. The names are different because different companies worked upon it, and a little bit difference is there in the architecture. So that is why different names have come up, right? So the focus of BERT was primarily for translation, but the focus of GPT was primarily on generating human-like text, right? Again, the difference is in the kind of data that has been used for training these models. Then reinforcement learning is a type of machine learning where we are training agents, or we are training robots, right? We cannot give the data related to the entire world to our robots, right? It's kind of you can say very tedious, very difficult thing to do, right? And it's not right also, right? You cannot give data related to everything. But if suppose we define a constraint that the agent has to work within an environment, or the robot has to work within an environment. Let me give you the example of the robots in the warehouse of Amazon, right? Amazon, Walmart, these companies are automating their warehouse. They are reducing the headcount, and they are increasing the number of robots working in their warehouses. So there is an environment. Let's say the warehouse is the environment within which the robot wants to work, right? So we can give certain kind of preliminary information to the robot that you have to work, you have to keep the product, you have to take the product, you have to package it, you have to put it into the logistics department, and then from there it will be dispatched and all that stuff. But how we are going to train this is the agent. I said it's kind of a robot. The environment is your warehouse, and we have certain kind of a reward punishment scheme, right? Like I said some time ago also, reinforcement learning is entirely based upon how you train your kids or how you train your pets. Supposingly you have a pet dog, if you would throw a bone, right, the dog is going to rush to the bone and bring it back to you, right? And then you pat the back of your dog, that well done, good job. That's a kind of a reward you are giving to the dog for doing a correct action, right? And in case the dog doesn't go, the dog keeps on sitting next to you, the dog doesn't go to pick up the bone, you would say something to your dog, that why didn't you go, right? You should go pick up the bone, right? Something like that, right? Or maybe I will not give you biscuits, right? Maybe he was eating biscuits, you take away the biscuits. So that is a kind of punishment you give to the dog. So what happens when these two different actions happen with the dog? The dog understands that if I go and pick up the bone, the chances of getting a patting on my back, right, getting a nice pat on my back increases, right? Every time I'm going to do this, I'll get a nice pat on my back, and every time I'm not going to do this, I'm going to get my biscuits will be snatched away, right? So this is what goes at the back end in the mind of the dog, right? Similarly, the kids that we have at our houses, right? If the kid is doing something wrong, supposedly the kid breaks the flower vase, you are going to give a nice scolding to the kid. So the kid is always scared of breaking the flower vase again. But if the kid studies on its own, you are going to give a chocolate. That's a kind of a reward you are giving to the child. So the child understands that if I study or if I pretend to study, I'm going to get chocolates, more and more chocolates. But if I break the flower vase, I'm going to get more and more scoldings. So in this way, what the child or the pet is going to do, it is going to do more actions that lead to the reward and do less actions that lead to the punishment, right? Similarly, in case of our agent in the reinforcement learning, the agent, whenever it does a correct action, we give a reward. Now here the reward is a numerical value. It can be plus 10 points or it can be minus 10 points, right? So if it does a correct action which is desirable for in the context of the environment, right? For example, the agent or the robot correctly picks the product which was required, right? It picks the right product from the shelf and then places it on the table where the packaging has to be done. It will get plus 10 points. But in case it picks up a wrong product from the shelf and then puts it on the packaging table, then it will get minus 10 points, right? So in this way, the agent or the robot is going to understand that I did something wrong here and I should not be repeating this in the future. So all the correct actions will be reinforced onto the robot, right? And all the incorrect actions will be deleted from its memory, will be kind of suppressed in its memory, and it will, by experience, by doing more and more actions, it will learn what actions are correct, what actions are incorrect, what actions it should do more, what actions it should do less. So all this entire thing is reinforcement learning. One example I already gave you, it's for training the robots. Another very important example is when you are when you want to play games, right? I hope you guys have played Ludo King on your mobile applications. There's an option to play it against the computer. So that computer is actually an AI model, right, which has been trained using the reinforcement learning concept, and it is capable of playing just like a human being and beating the human beings in the game, right? So other real world applications are AlphaGo. AlphaGo is a game, as you can see the middle image on the screen, this one, yellow one. This is the game of AlphaGo, right? And actually AlphaGo was the very first thing where reinforcement learning was applied, and because of the success that AlphaGo, it was able to beat the world champions, right? The AI that was trained to play AlphaGo using the reinforcement learning algorithms, it was, able to beat the world champions by a very good margin, right? So that was the breakthrough in reinforcement learning. Then robotics I already talked about, and the third place where this reinforcement learning is widely used is autonomous systems, autonomous cars, right? Self-driving cars, right? If the car makes a right turn and it was supposed to make a right turn, it gets a reward. If the car makes a left turn while it was supposed to make a right turn, it gives a punishment, that is minus 10 points, let's say. So that way the car learns that in what scenario, in what condition it should do what, right? So again, reinforcement learning is widely used in your self-driving cars and autonomous systems, right? So these are certain real world applications of your RL systems. Then this is very important, ethics and bias in AI, right? First of all, let's understand what is this bias, right? Our society, right, it's not an equal society, right? Everyone doesn't have the same privilege. So when we tend to collect our data, right, to train any kind of models, whether it's an image related data, whether it's text related data, any kind of data that we tend to create, right, the data inherently by default it will have certain kind of a bias. Like for example, if I give you, for example, if I tell you that there's an office who wants to create a face recognition system, right, for their office premises. There's a company XYZ who wants to create a face recognition system for their office premises, and they are collecting data of their employees for the same. Now what will happen, people who are working in the company, they are just one section of the society, right? Maybe the people who have good qualification, and the data that they will be collecting will be having images related to those people only. It won't have images related to the underrepresented sections, or let's say the people who are not capable of going to the office, right? So that introduces a bias. If we train the model on that kind of a data, that introduces a bias, that if that model gets deployed in a public setting, it will fail to identify people who are not capable of going to the office, or who don't have the skill set, or who don't have the required qualification to be able to work in an office. I hope you get the bias part, right? How the bias part. And the problem actually came here, right? You have an algorithm which is capable of identifying a white person, but it is not capable of identifying a black person. Why? Because it has been trained on a data which is absolutely about the white people, right? It hasn't seen any black human being during its training phase, so it's not able to recognize a black human being, right? So this is the bias that the AI models have, and these are actually leading to restricted adoption of AI in the public domain, right? Because people are concerned about their security, about their like how it is going to treat them in the future, right? If everything becomes AI powered, the bias will become more pronounced, right? Because AI doesn't has any any emotional or any you say what you say thinking ability of its own. It purely thinks based upon the data it has been trained. So if the bias is there in the data, the bias will be there in the model also, right? The bias can be related to racism, it can be related to sexism, right? If it has been trained on images of only men, it will not identify female, right? Then ageism, old people are there, new people, young people are not there, it will not identify young people, right? So all of these things introduce bias. Now what are the ethics? The ethics are actually the practices that we should be using, right? And we'll talk about ethics shortly. One more thing, black box nature, as I already said, whatever neural networks and Gen AI models we are talking about, we don't know how they are actually mathematically modeling the data we are giving, and how they are mathematically providing the outputs, because the number of calculations, the number of equations that are getting prepared is huge. Okay, so it's not quite easy to understand, and quite not easy to decipher how these things are working. So it's black box, entirely black box. So all of this again adds to the bias, right? But one of the primary reasons of bias is the data that the model has been trained on. Now again, talking about the ethics or the fair AI part, right? Fair AI or ethics, it's the same thing. So we have to ensure that our systems are fair. Whenever we are collecting data, we are preparing our data, we should have proper representation of all sections of a society. We should try to add the explainability quotient, right? To the explainability, this explainability quotient to the models, right? We should try that our models can explain, or some kind of a documentation is available as to how the model is working. Then we have certain robustness parameter, that it should be able to perform. Robustness means it is able to perform on every kind of data, no matter what. I mean, related to the objective, right? If it is face detection system, it should identify a white person similarly as it can identify a black person. Similarly, it can identify a young person. Similarly, it can identify an old person, right? So all kind of scenarios should be kept in mind while designing those systems, while training those models. Then transparency should be there, how the decision making is happening, that should be told to the people also who are using it. That it should be available, it shouldn't be like the people are not using it, right? And data privacy, obviously, if people are providing their data, providing their image as an input, it shouldn't be misused, right? Early days of AI, a lot of misuse started happening in warfare and all, right? So that is why this fair AI, ethics, biases, everything, creating awareness about all of these things became very much important, right? next we are going to talk about generative AI, right? This is again the hierarchy that I was talking about: artificial intelligence and machine learning. Then you have neural networks, deep learning, generative AI. Okay, so generative AI is the smallest subset out here, but again, this is the most in demand thing that is going to be there in the next decade, right? So any kind of model that is capable of generating new data, be it music, as I said, be it text, be it videos, be it images, any kind of thing that is getting created by a mathematical model, by an algorithm, that comes under the umbrella of Gen AI. Then we have different types of generative models, right? We have variational autoencoders model, right? This might be a little bit bouncing off. It's quite complicated, but yeah, I'll try to explain. So variational autoencoders, they are based on the concept of autoencoders, which have an encoder decoder architecture. Again, the transformer part comes into the picture. There's an encoder decoder architecture, and the objective is whatever is the input, you have to create similar kind of an image with the decoder. So what autoencoders they try to do, they take an input image, they try to modify it, and then try to reconstruct the image, similar kind of an image. So that's a variational autoencoder model, how it works. In very simple words, I'm telling. Then we have generative adversarial networks. I already talked about this in the beginning also. Deep fake generation happens by this. So they have two parts. One is the generator and one is the discriminator. Now again, generator is one convolutional neural network, discriminator is another convolutional neural network, as you can see here, right? This is one CNN, this is another CNN architecture, right? So generator is going to create an image and pass it to the discriminator. Discriminator serves as the detective. It tries to identify whether the image that has been provided to it as the input is a fake image or a real image. In case the discriminator says that this is a real image, the image is given out as an output, and the generator has been successful in creating the new image, right? But in case the discriminator says this is a fake image, then the generator has failed, and that response goes back to the generator, and it again trains itself. It again adjusts the equations that it has prepared for creating that image, and again generates a new image. So it's an iterative process, and you can do to 1000 or iterations, or 10,000 iterations, or even 1 lakh iterations. The more the number of iterations, the better the generator will be at creating new images. So that is how the GANs are working, and that is how they are generating deepfakes with the help of this GAN architecture. Then you have diffusion models. This is the breakthrough in image generation, right? These are early models, and then diffusion models, these have come up recently. They are based upon a concept called stable diffusion. The image, whatever training data they have, they first mutilate that input image up to a point that it is pure noise, it becomes unrecognizable, right? So that is diffusion models. And after the noise is made, like the images are converted to noise, it tries to reconstruct those images, and when it reconstructs, it becomes a new image, right? So this is a new image that gets created here. So this concept of stable diffusion, it keeps on adding noise to the input image, tries to mutilate it, damage it to a point where it's purely noise, the image is purely noise. And again, purely noise means it's all blur, you will not be able to make out anything from your naked eye, right? And then it tries to remove that raw noise in several iterations. Again, here the iterations can be from 1000 to 10,000 or even 1 lakh, right? The more the number of iterations, the better the quality of the generated image. Now again, one thing that I would like to mention here, you can see I'm talking about so many iterations. It's a very resource intensive process. When you want to train generative AI models, you require a lot of energy, that is power consumption, uninterrupted power supply, a good processing unit, right? It won't do with CPU, right? Your simple laptops are not capable of doing Gen AI. You need TPUs or GPUs, tensor processing units, TPUs, or graphical processing units as GPUs, right? You need that capability. You also need a lot of data initially to train your models, right? And besides this, you also need a lot of memory, a lot of storage capacity to create Gen AI models, right? So all of this, creating models from scratch, it's quite a complex task, right? And people are really confused between two things. Creating this Gen AI model from scratch is one thing, but fine tuning Gen AI models, right? Using the existing models, like using the API of ChatGPT, API of Meta AI, or API of Llama model, right? To fine tune it and use it for your task, that is an entirely different thing. So what currently the learning perspective is, you should be knowing how to fine tune, right? And it's a bonus if you know how to create those architectures from scratch, because the then imagination is your limit, you can create new things, right? But fine tuning these models which are already existing in the market, a lot of Gen AI models are existing, and because of the extensive requirements, it is not possible for an individual, for a learner, to create it from scratch, right? Even if you train it for 100 epochs or 500 epochs, by anyhow, by any chance, by managing the resources, you won't get the desired results, right? So it's a wasteful expenditure that happens. So only big companies, Google, Meta, you have Tesla, all of these big companies, they are investing heavily into the resources, and maybe in years to come there will be scenarios where we can get those resources readily available and train our own Gen AI models. But as of today, fine tuning part is something that is very much in demand, and companies are looking ahead to, especially small to medium ranged companies. Now, applications. Text generation, as I already said, you can create news articles, blog posts, product descriptions, GPT models. Chat GPT is a very popular example. Even Meta AI is doing very good, right? Gemini is a little bit lagging behind, right? Because I've used all of them. So I feel the same prompts, if you put into the different large language models, you will be able to see the different um, outputs they are generating, the different answers they are generating. And that the difference is primarily because of that kind of data they have been trained on, right? Then images, you have DALI, you have stable diffusion, as I was explaining stable diffusion, right? So these are different models that are used for image generation. So image generation, you have text to image generation also, you have image to image generation also, right? So DALI and stable diffusion can generate images from text, right? But if you want to upload a base image and then you want to generate a new image which is similar to it, that is also possible. That is image to image generation. Music generation is there, you can create entirely new music tracks, like pure music. I'm not talking about the singing part, the music part, that is possible. And recently you have seen news anchors have come up, right? Who can read whatever input you provide, and the lip movement is also there, the eyebrow movement is also there, eye movement is also there. So that is video generation actually, and that is deep fake actually. That is the generative adversarial networks that are doing that, that are responsible for those AI news anchor thing, right? Then we have art and creativity, right? They are trained on artistic works like paintings and literature, like um, famous painters and famous writers that have been there, their works have been used as the input data for training algorithms. And based upon that learning, the model can generate a new painting, or it can generate a new story similar to what the author had worked upon, right? Like if you want to more versions of Harry Potter to come into future, right? And JK Rowling refuses that, no, I'm not going to write any other versions of Harry Potter. But you can create a model, train it on the data of Harry Potter, all the books of Harry Potter that have been written by JK Rowling so far. And yeah, you can have another variant, another story fit for a movie, right, of Harry Potter, or another book, right, created by AI. So all of those things are possible, but again, AI matching the ability of human beings, that's very far, right? That's very far. That so we have that stage uh, that will come up where AI will be able to supersede the human intelligence, but it's not anywhere near us, right? It will take hundreds of years to come, right? And yeah, so these are applications of generative AI. You can generate marketing content, sales content, support content, general writing, note taking. All of these things are possible. Recently one AI product has come up which can take meeting notes also, right? So you are talking in the meeting, it will take entire notes of your meeting, give you minutes to minutes, give you the next steps that you should be taking after the meeting. Everything is it's capable of doing. Okay, so that's also generative AI only. Then you can do code generation, text to SQL conversion, web apps builder. All of these things are possible related to coding. A lot of help is available out there, but again, the generations are correct or not, that the model will always give you a disclaimer that I'm giving you this code, but there is a chance that this code can be incorrect. So you have to have your ability or you have to have your own knowledge in order to judge whether the code that has been provided to me, that's the correct code or not. Then image generation, we already talked about. We have generation also, right? Text to voice, as I talked about the news anchors, that is voice synthesis. Video editing, video generation, 3D models, right? Like for example, if you give an architecture design to a model, it is able to plot it in 3D and give you an entire 3D structure. So that's 3D model generation. Then you have other applications you have in gaming, the AR VR part, right? Creating those virtual environments, that is there with Gen AI, RPA, music, audio, biochemistry, and biology also. In drug discovery, right? Medicines. Gen AI is being a lot of there's a lot of use of Gen AI in like in discovering new drugs which could be life saving, right? So these are about the applications of Gen AI. NLP and large language models, transformers, GPT-3, GPT-4, these are the recent models by OpenAI, right, that excel in tasks like text generation, conversation, and content creation. The term large language models actually mean that this model is capable of doing more than one task. That is why it's a large language model. It's not a, it's a transformer architecture. You can see in the diagram below. But the term large language model implies it can do summarization also. You give a large piece of text, ask to summarize, that is there. You give a document and you ask questions based upon that document, that is possible. You can do a conversation with these models, you can do content creation with these models. So LLMs can do multiple tasks but related to text only, right, in a chat format. So that is the LLM part. BERT we have already talked about. Then practical applications, we have chatbots, right? Chatbots are a very good example of Gen AI. Then we have content summarization. As I said, you can give a large piece of text and then you can ask it to summarize. Then we have translation. You can give text in one language and ask the model to convert it into another language. And Google Translate, right? This was the actual problem point which led to transformers and breakthrough in Gen AI. So yeah, so this is pretty much it about the practical applications. Now, hands-on and demos. So I'd like to show you one code file. Um, just a second.
So Zainab, can I ask
Mm.
something?
Yes,
Yes,
please.
to the group. So any question you have, you can always put that. Maybe anyone, I mean, any kind of background you have, so that like Mr. Ashok Gupta was from the architecture department. He's an architect. And anyone else is there who want to share something? Maybe
Yeah,
healthcare.
hello, sir and ma'am. Actually, I have one question.
Mm-hmm.
The overall
Mhm.
presentation is good. I got a really good understanding, clarity of the like the all these stuffs. My question is, as I belong from the pharma industry, so how it will
Mhm.
help in my job roles? So how it will like generative AI, advanced AI, how it will help in that
Uh,
perspective?
Absolutely, absolutely. Actually, Zanab ma'am has actually shared the same thing in the PPT,
Yeah,
but still, I
yeah,
would like to highlight something more on that. I'm sure that, I mean, at the time of COVID vaccination, you might have seen that with the help of AI, the drug was invented, right? Isn't it?
yes, 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 yes,
So
right.
see, I mean, how exactly pharmaceutical company, say about an example of Dr. Reddy or maybe Cipla ran vaccine, any of the new diseases come, so in case they want to actually help with the drug, then with the help of generative AI, there will be a simulating molecular part, and interaction with predicting potential compounds on that can enhance a clinical trial design out there. And the best part is that AI can improve pharma vigilance and by analyzing a vast data set. Because as ma'am said that AI would be paralysis without a help of data, right? So data sets when you have, they can identify with the help of generative AI to have a very important adverse situation wherein they can personalize the medicine accordingly to your disease, and that can be on a trial basis. So the You might have seen a lot of medical big pharmaceutical company. They keep on doing research, right? They have a research and development team, right? R&D team and other things, right? So they have a bunch of people, as a generative AI. So by the way, I would say a lot of people, when they come, when you speak about AI, machine learning, deep learning, a lot of people think that it's a part of an IT industry, information technology industry, but it's not actually the truth. Trust me. So AI, generative AI, each and everything, like ma'am said about media, right? Media world. So everywhere you have a chances. So it's not a kind of a domain. Forget about that. You are changing your career. Number one, in case you are in a pharmaceutical industry, you can always enhance this particular things under your belt so that you can have a kind of momentum in your present company itself. Rather than changing a career, you have to be there at present at your situation only. Fine, at your present job. So any uh, doubt you have still, or do you have want to, so that ma'am can clear it?
No, no, no. My doubt is clear.
All right. So it's better that in case I may I know how long you have been with the pharmaceutical industry.
For 5 years, like from
All
the
right. So
like
you
there is
have
a
given
overall
your
five.
overall 5 years. So you have given a lot of time to the pharmaceutical industry, right? Almost like you,
Yes,
in case you enhance your career, because pharma industry is something which is not going to be ever down. Pharma industry, that is called coming under healthcare industry, number one. Then banking and finance, it cannot be never down. Any bank can get shut down, but as an overall bank cannot, as a financial organization cannot get shut down, right? So these are some of the industry where you have a lot of career prospects. You can enhance your career to that level. Got it, Mr. Bhushan?
yes, yes, yes.
Thank you so much. Yes, Malar, do you want to ask any question? Zainab is there, I'm there, so that we can help you out. Yeah, Mr. Malar, you unmuted, I believe. No worries for that. Yes, Zainab, I mean, you can please continue. I'm so sorry to interrupt you.
No worries. It's good.
Thank you.
All right. So I'm quickly showing you how you can create. I'm not going into the fine tuning part again, because that would be very difficult for you to understand at the moment. But I'm just showing you one like architecture of this generative adversarial network GANs that we talked about in the Gen AI part, so that you have an understanding how the code works, how the things are getting created, right? So here if you see, this is I'm loading the different Python libraries. I don't know if you guys know about Python or not, but when you want, and as I said, someone was asking that how much math should I know. Python is a very simple language. It's like writing in plain English, so you can see, right? So I'm just importing the name of the library, importing this library, importing this library, simply writing import, import, import. After that, this is the generator. I said GAN has two parts. One is generator, one is discriminator. So here we are building the disk generator part, which is going to create a new image, right? And every time it creates a new image, it will be passed on to the discriminator. Now as you see, this is one neural network architecture, and this discriminator is another neural network architecture, right? So again, here I haven't used any convolutional layers. It's purely dense layer, dense layer, dense layer. It's a new simple neural network, or you can say artificial neural network, ANN, right? And here also discriminator, we have a flattening layer, then we have dense layers, right? And based upon all of this, this is a and another artificial neural network, right? So generator will create the image, discriminator will again work upon that created image to find out if it is real or it is a fake image. If in case the discriminator says that it's a fake image, it will go back to the generator with the feedback, right, where it failed, right, in creating an image, and then it's going to regenerate that image. So that's how it works. So we have defined the generator. How it happens in code, that is something I'm trying to show here, right? This is your generator code. This is the discriminator code that we have written. Now here we are defining the training part, right? So I'm passing parameters here. These are known as the parameters that we pass, and def is used for defining a function in Python. So here I'm defining a new function called as train GAN. train underscore GAN is the name of the function. Generator, discriminator, these are the neural networks that I'm passing. Epochs I have mentioned as 501, right? I'm training it for a very less number of epoch. Again, reiterating the fact, this is not sufficient. The output that we are getting, that I'm getting currently, it's not a very good output, because at least 10,000 or 1 lakh epochs are required to train your GAN very properly, right? To be able to create those deep fakes, right? Then batch size is 128. Batch size indicates that how many images from the data set will be passed at once to the model, right? So a total of 128 images from the entire set of images that we have will be passed to the model in the very first stage. It will generate fake images based upon all those 128 images, pass them to the discriminator. Discriminator will generate predictions for all of those 128 images, whether it's real, whether it's fake. There will be 128 predictions along with the feedback that go back to the generator. Now, based upon that feedback, the generator is going to modify its equations, modify the processing it was doing in the backend, and again create images for those same images. Right, again pass it to the discriminator. So for 501 cycles, epochs are actually the number of iterations or the number of cycles that this will be repeated. So for 501 cycles this will be repeated. And here I'm using the MNS data. MNS data is actually a data of handwritten numbers, right? These are images where handwritten numbers are there, 1 2 3 4 digits are there from 0 to 9. Okay, so I'm using that data. I'm compiling my discriminator, right? And this is the GAN architecture actually. So I'm giving an input image. The shape of the image is 100. That is 100 is the dimension of the image. Generated image is generator GAN input. So to the generator, we are passing the GAN input. From the discriminator, we are saying the its trainable is false. GAN output is equal to discriminator generated image. So whatever image has been generated by the generator, it passes to the discriminator and we get a GAN output, which is actually the feedback. And then we create the model, we compile the model. So it's a function. When we will call this function, then the model will actually be created, right? But this is function is actually for reusability by modifying a little portion. Then this is the training loop that we have created for epoch. In the range of epochs, 501 epochs are there. So it's going to create real images, it is going to retain the real image, we are going to create fake image, it is going to calculate the loss in AI is actually the error that the model is making, right? So it's going to compare the fake image with the real image and try to analyze how much error is there that it will be representing with the loss. So loss underscore real, loss underscore fake, right? For the real image, for the fake image, all of that loss will be there. And this loss is actually going to be again a kind of feedback to the generator. Then it's kind of adding some noise in the generator to change the output that is going to come. Concept of little bit hint related to stable diffusion only, right? By adding noise we can change the image, right? Again, that noise is not visible to the naked eye, but yes, mathematically the distribution of the pixels in the image that will change, right? Then we have the GAN loss, the entire loss for the GAN. Then printing the progress after every 250 epochs, I want to print the output that is currently there, right? So, and along with the loss values that are coming, the errors that are coming. So plot generated image by the generator, whatever image has been generated, that also we want to plot, right? So here I'm finally calling, this is the function for plotting the images that are getting generated. So I'm not explaining it, it's related to visualization part. Again, here I am calling the different functions that we have created above. Generator is equal to build generator function, discriminator, build discriminator function, and train GAN passing the generator and the discriminator. The epoch information and the batch size we have already passed, so there is no need to pass it again when you're calling the function, right? So in the very initial phase, this is epoch number 1, that is the first training cycle. The images look something like this, 100% noise is there, right? By the images created by the generator look something like this. Again, the discriminator gives a feedback and it keeps on iteratively improving the images, and at the end of 250 epochs this is the kind of image that looks like. So now you can see there is a progress from epoch 0 to epoch 50, right? The kind of image generated at epoch 0 was very worse, right? It's purely noise. But the kind of image generated at epoch 250 is much better, it's much enhanced. And so if we keep on training it for at least 1000 cycles, for 10,000 cycles, or for 1 lakh cycles, we would be able to see really good new images of handwritten numbers here, right? So actually, my local machine, I cannot do this, right? I already explained it's a very resource intensive and costly procedure. But if we have the capability, if we have the GPUs available, we have the memory, we have the resource compliances or the resource requirements fulfilled, we can train it for 1000 or 10,000 epochs, and you can see that new images will be generated, right? So this was pretty much it about the GANs part. So I will stop sharing my screen and we can go back to the PPT, right? Right, so that was a little bit insight into how the code works, right? Not much into the detail, because right now, because when the basics, right, when you start from machine learning or you start from the very basics part, right, from data analysis, then you slowly build upon the concepts, and these things would be easily understood, right? So not going much into the detail. Then these are the different programs. I think Subir would be able to guide better. We have different programs available. We have a program in Gen AI, we have program in artificial intelligence and machine learning, data science and business analytics, business intelligence and data visualization, and big data analytics. So these are the different programs based upon your interest, based upon your like alignment with your industry, what you want to do. You can get started, right? But straight away jumping to Gen AI, that is what I was trying to explain throughout the presentation. Straight away jumping to Gen AI is not a good thing, right?
Absolutely, Ms. Janab. So,
Mm,
see, if I talk about generative AI, it's yes, it's a new thing in the market, but eventually, when you start for the basics and you enter into the data world, then only you can take a promotion on that, right? So, in case we know about data science, we are doing machine learning, then it's something which can be actually fruitful generative AI. In case you still want to join and you have eagerness to learn, we are starting it from the scratch also. So not to worry about it. But yes, eventually, I would say always in case you think that yes, you need the basics to be strong, then I would say a lot of other programs we have. You can always put an inquiry in the group, because that's an open group which we have created. And anyway, I mean, my team would actually share you the number, mine, so that you can always directly connect with me for a better explanation, and we can have a one-on-one session also for that, in case that is required. All right.
yeah, so that's it from my end. uh,
So any query you have, anyone?
any questions? If anyone wants to ask anything related to AI, Gen AI, advanced AI, anything anyone wants to ask, I'll be happy to answer. Arun Kumar, you can unmute yourself and you can say whatever you want.
Yeah, good evening, ma'am. My name is Arun Kumar. Good evening, sir.
Good evening.
Yeah, the session was really good. So I have few questions I just want to ask you. The first thing would be like when it comes to application in generative AI. We're talking
Hmm.
about generative AI. So
Hmm.
we was taking through that part. So there, when when a document is being shared or being explained or it's being presented, so
Hmm.
the document or it directly takes it as a meeting notes and everything is being answered and all the stuff. So,
Yeah,
will it possible for multiple presenters?
yeah, it's possible. It's existing in the market.
Perfect. Yeah, and also, ma'am, like regarding large language LLM. So,
Hmm.
is that LLM access only the text content, or it will be summarizing only the text content, or including the pics and videos as well?
No, currently LLMs, see, LLMs are based upon transformers. Transformers are for text data, right? So any kind of LLM you want to work with, it is purely for text data. But recently, the update that has come, if you work with GPT-4 or such
Uh-huh.
like equivalent models, if you give them a document with the images and the videos and everything, and you want a summary out of it, they are capable of doing that. And how they are doing that is they are using their brother sister applications, right? Like as I said, OpenAI has DALI also, right? And then you have Mid Journey, you have different other tools available, Gen AI tools only. So the image part, it will give it to another tool, take the output from the tool and add it to the text. Okay, it is going to intertwine it with the text output that it is generating, right? Similarly, if you have a certain kind of a graph, right, it is going to pass it to the Python terminal and it will say, "You interpret this graph and give it to me, like convert this numerical data into a graph," and then it will put that graph into the output that it is generating. So likewise, it's using the existing infrastructure of computing, or existing different models. There's a communication possible nowadays between the different AI models that are hosted on the same platform. And based on that, they are able to read your videos also. They are able to decipher what is there in the videos. They are able to understand what you are saying in a voice command, right? If you give a voice command these days, it's possible that it will give you a text answer based upon that voice command also, right? So recent advancements are coming up. These things are that is what I'm saying. The next 10 decades are about all of these things only.
Okay, good. So, thank you, ma'am, for the response. And last question. Everyone now wanted to move as the technologies and the innovation is getting improved day by day.
Your
Everyone
voice
want.
volume is very low. I'm not able to hear clearly. So sorry.
I'm sorry, ma'am. I have bad throat because of the climate. Can you hear me now?
Yeah, now it's clear. Yeah,
One
better.
minute. It's better now, ma'am.
Yeah, but there's a lot of noise.
Okay, okay, fine. I'm sorry for that. So I'm audible, right?
Yeah, you're audible. Yes.
Okay, ma'am. So thing is like, so everyone wanted to move towards AI and they want to use the tools and the like more extensive tools which has been launched in the market as of now, as GPT
Hmm.
3 and 4 and also 5 is being
Hmm.
developed. Meta also
Hmm.
has been interchanged. So and when we are
Hmm.
in this particular point of everyone want to move to AI and generative AI.
Yeah,
So
everybody wants
when
to move. Yes.
so when people want to do that, so the basic things what we want is we need to be strong in data analytics and data science. So
Yes, the
we at least
basic
minimum
concepts have to be
basic.
strong. If you want
Correct.
to, there are there are two things. One is creating those models from scratch. Again repeating the thing, and one is fine tuning the existing models. Right? ChatGPT
Uh-huh.
API is available. You can use that API to create your own chatbot, right? By fine
Correct.
tuning it on a smaller data set, right? But for that, there is another concept called transfer learning that you should be aware of. Again,
Yes.
jumping straight away to Gen AI, that is something I won't recommend.
Yeah, that's what really wanted. I wanted to be clear about it because it's very difficult as well. We need to know the coding part, the programming part as well, and we need to be at
See,
least
learning
at least
Python
basic
is
should be
not
there.
difficult until unless you are dedicated. It's a very easy programming language. If you are
Yeah. So
dedicated enough, you can do. And if I tell you about myself, I have done a career transition only. Right, I was in the marketing industry for quite 5 6 years, and there
okay.
I used to work with a lot of data on Excel, right? And I
Uh-huh.
used to do analysis on Excel. That was the point where I thought of doing my upskilling, and I chose a good institution to do my upskilling. And here I am working with machine learning, deep learning, and even Gen AI, right? So it doesn't takes a lot of time for you to come from machine learning to Gen AI. That is also I would like to tell everyone, right? If you start today, within 2 years, I would say 1 year or 2 year, you can reach the point where you are well aware of everything Gen AI, everything related to Gen AI, right? But the
Okay.
starting point has to be from the basics.
Okay, got it. And last, just want to clarify this. So,
Hmm.
in order to become a better business acumen, so is this mandatory that I need to stick on to AI and generative AI?
Business acumen.
Yeah,
No, I wouldn't say that. Like, what do you do currently?
yeah. Currently, I'm a engineering background person, so
Hmm.
I'm working as of now. I'm home.
Okay, okay. So see, business acumen, or like if you want to create products and market it yourself, like you want to do entrepreneurship, right?
Uh-huh.
You want to create AI related projects and you want to create your own company based upon those products or based upon those services, right? Then you need to have business acumen. Then I understand. But if you want to work as a team member in any of the reputed companies, let's say in Meta or in Google or in any of the small startups, you want to be the CTO, let's say leading the AI wing, right? So there you don't need a lot of business acumen. There you have to be more focused on the technical knowledge.
Okay, yeah,
So
that's
it
not my
depends
cup of
upon the role that you want to opt for.
got it, got it. So I'm more over into business development, sales and marketing.
Hmm.
Yeah, I'm
Okay.
more over into management segment.
Mhm. So I have answered the question already, so you can
Yes,
choose
yes, I got it.
accordingly, right?
Yeah, yeah, I got it.
Yeah.
Ma'am. Thank you.
So,
So,
Mr.
now,
Arun, what you have to do is
okay, sir.
start your career directly into the data world as you're from a
Hmm.
business development. So I would actually recommend you that you should always start your career as a business analytics. You should learn
Okay,
the visualization tool. You should know
exactly.
because in a sales professional also you need to actually pivot the visualization tool because see to be very frank Excel the formulas it's very difficult these days to a lot of people to go ahead and inculcate the same thing, right? But if you talk
Yes.
about Power BI there is a single button out there as simple as that, so
Hmm.
that can actually really help you out to visualize the same thing. And then once you have your team, you are handling a team, you can always share those data and can see then how exactly the sales process is going on or the team process is going on, right? So you
Okay.
can always do some projects from based on large data sets module like Amazon sales process, and you can forward them into Power BI or maybe a visualization tool with like Tableau you can do always. So this can help you out to analyze the things. So slowly and steadily you can move up to the ladder of generative AI. So you need to start your career at some point of time. Maybe as a data analytics, maybe as a data scientist, also you do it, but you need to understand the basics concept first, and then only you can move up to the ladder.
Okay. Got it.
And
Thank
it's
you.
not changing your career, trust me. These data science, AI, machine learning is there in each and every sector. You name me any n number of industry, I would say it is there in each and every sector. It
Oh,
is not a
got it. Got
domain
it.
of studies.
So we don't need to change the domain of the career. We can stick on the same thing and we can
It
excel.
depend upon you. In case you want to change the domain, you should start your career on a better role so that you have the basic understanding first.
Uh-huh. Okay, sir. Got it. Thank you.
Thank you. Yes, anyone do have more question? I believe, I mean, people are not actually willing to ask or what. I mean, still, in case you have any question, kindly do let us know. Because what we do always, we have done a couple of, master classes in US also. So that was more kind of wherein, people were asking a lot of questions. So these master classes are a basic understanding. So in case still you have any questions, you can always put that to our, consultant, and we'd be more than happy to help you out. And we have our headquarter in, I mean, sorry, if I talk about our corporate office in New York Street, that is in 26 Broadway. We have opened up a recent office in Dubai also, and our registered office is in Noida, and we have one more office is in Bangalore. So, but again, Bangalore office people are working from home. You can always, connect with our learning consultant. They will be more than happy to help you out. All right. So, Zana ma'am, can we end up the things or on a good note?
Yeah. Yes, I think we can conclude. And it was nice taking this session, and I look forward to like these people, maybe training these people in the future.
Sure, definitely. And if you have any question, please, yes, you can unmute. I mean, we are there for 5 minutes. Yeah, Mr. Mahmood, you have also there. I mean, I believe you are from Kuwait, right?
Yes, yes.
Yes, absolutely. So, sir, any question you have, please?
No, no, I don't have. It was very like a lot of knowledge here. I gained a lot of
Oh,
knowledge.
all
Thanks a
right.
lot to the instructors, and it was very interesting actually.
And Mr. Mahmood, I will personally connect with you. I believe one of my learning consultant has tried connecting with you. He gave me that your name and details. So he was Sam Joseph. So I will take the number of from him, and then I will try to connect with you tomorrow. Tomorrow,
Okay.
may I know what time you'd be free?
Yeah, yeah. After 6 p.m., I always become free.
All right. So probably I can give you a call around post 6:30, so you can have a cup of coffee or tea, and then we can talk. Okay.
Okay, perfect.
Sure.
Thank
Then.
you.
Thank you so much.
Thank you.
All right. So, any other question, Mr. Murugan?
Thank you very much.
Thank you so much, Mr. Murugan. Ashish, do you have any question? Ajay? No worries with that. So we'll get in touch with you, and we can always, any question you have, we can always, come across those things. Thank you, and so let's end up the things on a good note. Thank you, and have a great rest of the day, and wish you all the best for your career success.
Thank you. Thank you.
You're most welcome.